Pair of straight lines, part 3.
Hi, hello everyone. So see the continuation of previous part. So see the third theorem. Show that the product of the perpendicular distance from a point alpha comma beta to the pair of straight lines is modulus of a alpha square plus 2h alpha beta plus b beta square by square root of a minus b whole square plus 4h square. Okay. So clearly this is the homogeneous second degree equation. So it represents two homogeneous linear equations. Now perpendicular distance from alpha comma beta to the first straight line and perpendicular distance from alpha comma beta to second straight line. Now product of that perpendicular distance is this one. Okay. So here let ax square plus 2hxy plus by square is equals to 0. So represents two lines. B. Here, this is equation 1. L1x plus M1y is equals to 0. This is equation 2. And L2x plus M2y is equals to 0. So this is equation 3. So clearly it represents these two equations. So this can be written as product of these two lines. So therefore ax square plus 2hxy plus by square. So this is equals to L1x plus M1y into L2x plus M2y. Now product of these two lines. So what you get? L1 L2 x square. Next plus L1 M2 plus L2 M1 xy plus M1 M2 y square. Now comparing the quotients. So you are comparing the quotients. So clearly x square quotient is A on LHS, on RHS, L1 M2. And xy quotient is 2h on LHS, on RHS, L1 M2 plus L2 M2. Next, y square quotient on LHS is B, on RHS is M1 M2. Okay. Now let D1 is perpendicular distance from alpha comma beta to which equation? Equation 2. Now D1 is equals to what formula? Modulus of ax1 plus by1 plus c by square root of a square plus b square. So this is the perpendicular distance from the point x1 comma y1 to the line ax plus by plus c equals to 0. So clearly this is equals to what is A? A is L1 into alpha. So L1 alpha plus M1 beta. So divide by square root of L1 square plus M1 square. So this is D1. Next similarly, and D2 is perpendicular distance from alpha comma beta to equation 3. So clear what is that? So we have to use same formula. Here replace L1 M1 by L2 M2. That is modulus of L2 alpha plus M2 beta. So divide by square root of L2 square plus M2 square. Okay. Now product of the perpendicular distance from point to the straight lines. So means D1 and D2. So therefore the product of perpendicular distances. So what is that? D1 D2 is equals to modulus of L1 alpha plus M1 beta divided by square root of L1 square plus M1 square into L2 alpha plus M2 beta. So divide by square root of L2 square plus M2 square. Now multiplying these two. See here what you get. First into first. L1 L2. So L1 L2 alpha square plus L1 M2 alpha beta. Next M1 L2 alpha beta. That is L1 M2 plus L2 M1 of alpha beta. Next last one. M1 M2 beta square. So divide by square root of. Again multiplying these two. That is L1 L2 whole square plus L1 M2 whole square plus M1 L2 whole square plus M1 M2 whole square. Okay. Now what is L1 L2? See here this, that is A. So D1 D2 is equals to A alpha square plus L1 M2 plus L2 M1, that is 2H. So 2H alpha beta plus B beta square. So divide by square root of. See here this is A square plus B square. So that can be written as A minus B. So for first and last we have to apply the formula A square plus B square. That is A minus B whole square plus 2AB. So clear, that is L1 L2 minus M1 M2 whole square plus 2L1 L2 M1 M2. Okay. So for second and third, see here A square plus B square. We have to apply A plus B whole square minus 2A. That is plus L1 M2 plus L2 M1 whole square minus 2L1 L2 M1 M2. So these two terms are get cancelled. Now what you get? A alpha square plus 2H alpha beta plus B beta square. So divide by square root of L1 L2 A, M1 M2 B. So A minus B whole square plus this is what? 2H only now. So 2H whole square. You will get 4H square. So this is the product of the perpendicular distances from alpha comma beta to the pair of straight lines. So see the next theorem. So that area of the triangle formed by the lines and Lx plus My plus N equals 0 is this one. Okay. So see a solution. Proof. See here first. Let ax square plus 2hxy plus by square is equals to 0. So represents two lines. B. See here one is L1x plus M1y is equals to 0. Next one L2x plus M2y is equals to 0. So this is equation 1, this is equation 2, this is equation 3. So therefore clearly this equation is equals to product of these two lines. So ax square plus 2hxy plus by square, this is equals to L1x plus M1y into L2x plus M2y. Now comparing the quotients, I am writing directly. So A is equals to L1 L2, 2h is equals to L1 M2 plus L2 M1. Next B is equals to M1 M2. Okay. Now given line Lx plus My plus N is equals to 0. This is equation 4. Now see here, this equation represents two lines. This is homogeneous equation. It represents two homogeneous linear equations. So see here, consider the coordinate axis. This is x and y axis. So clearly, homogeneous equations are passing through the origin. So this is equation 2. And this is equation 3. And this is what Lx plus My plus N equals 0. Okay. Area of the triangle formed by these three lines. So this is another line. So this line is Lx plus My plus N is equals to 0. Okay. Now you need to find the area of this triangle. Okay. So clearly you need to find first points of intersection of three lengths. Okay. So for that we have to solve equation 2 and 3 first. So solving 2 and 3. So clearly we get origin only now. So because of these are two homogeneous equations passing through the origin. Therefore point of intersection of these two is origin only. You get O 0 comma 0. And solving 2 and 4. So solving equation 2 and equation 4. See here, write x, y constant. And so you observe the equation 2. So here m1 0. You have to start from second term m1 next to 0, l1 m1. Next here mn l m. Okay. The cross multiplication here. So clearly, what is x value? X by m1n minus 0, that is m1n, and y by 0 minus l1n, that is minus l1n, and constant by l1m minus lm1, l1m minus lm1. Therefore the point is what? X comma y, that is minus x comma y. What is x value? m1n. See, you are equating first and last. So what you get? m1n by l1m minus lm1, comma, equating second and last, you will get y coordinate, that is minus l1n by l1m minus lm1. So this is x1, y1. Okay. So similarly, solving 3 and 4. Okay. So you get vertex B. So what is that? Just replacing L1 M1 by L2 M2. Okay. You will get same point. See here, that is M2 M by L2 M minus LM2, comma, minus L2 M by L2 M minus L1. You are replacing L1 and M1 by L2 M2. So this is what? X2, Y2. Therefore you need to find area. So clearly we have 3 points. So therefore area of triangle OAB is what? Of modulus of x1 y2 minus x2 y1. Okay. So here this is x1 y1, this is x2 y2. So here therefore this is equals to half into. So what is x1? This one only now. m1n divided by l1m minus lm1 into y2, this one, minus l2n by l2m minus lm2 minus x2, this one, m2n by l2m minus lm2 into y1, this one, minus l1n by l1m minus lm1. Okay. So this is equals to half into. So what is the LCM? This one only. So LCM is L1m minus Lm1 into L2m minus Lm2. So clearly both denominators are same. You have to add the numerators. Here, see the second term minus into minus plus. So first you have to write plus term. So this is L1 M2 M square. L1 M2 M square. Minus write first term L2 M1 M square. L2 M1 M square. So in both terms M square is common. This is half into modulus of L square into L1 M2 minus L2 M1. So divide by multiplying denominator. So what you get? L1 L2 M square. Next, first into last, that is minus L1 M2 LM. Next, second into first, minus L2 M1. So this is M2 only, L2 M1 LM plus M1 M2 L square. Okay. So here this is 1 by 2 times of L square into A minus B. How to write A minus B? Square root of A plus B whole square minus 2AB. Okay. That is L1 M2 plus L2 M1 whole square minus 4AB. That is 4 times of A into B. So what is A? L1 into B is L2 M1. So L1 L2 M1 M2. Okay. So divide by. See here L1 L2 M square. In both terms LM is common. So minus LM is common. You will get L1 M2 plus L2 M1 of LM plus M1 M2 L square. Okay. 1 by 2 into M square into square root of 2H whole square minus 4 into L1 L2 is A, M1 M2 is B. It is minus 4AB. So divide by again L1 L2 A only no, A M square minus L1 M2 plus L2 M1 value, that is 2H. So 2H LM. Next M1 M2 value B, that is plus B L square. So here 2 square, here 4. So clearly in both terms 4 is common. You will get 1 by 2 times of 2m square into square root of h square minus ab by am square minus 2hlm plus bm square. So 2 to 8 cancel. So this is what modulus of m square into h square minus ab by am square minus 2hlm plus bn square. So this is the required area of the triangle. So next we will discuss few problems. So see the first one. Find the center and the area of the triangle formed by the lines. Okay. So see our solution. So given 12x square minus 20xy plus 7y square is equals to 0. This is equation 1. Okay. So clear it is a homogeneous equation. It represents two homogeneous linear equations. So clearly find that equations. So 12 into 7, 84. So what are the factors? Minus 14, minus 6. So this can be written as 12x square minus 14xy minus 6xy plus 7y square is equals to 0. See here in both terms 2x is common. We will get 6x minus 7. In both terms minus y is common. You will get 6x minus 7y is equals to 0. Again 6x minus 7y is common. You will get 2x minus y is equals to 0. So therefore 6x minus 7y is equals to 0. This is equation 2. And 2x minus y is equals to 0. This is equation 3. And given 2x minus 3y plus 4 is equals to 0. This is equation 4. Okay. Now here you need to find center and the area of the triangle. So see here, consider the coordinate axis. So this is the origin. Okay. So see here, this is a homogeneous equation. It is passing through the origin. It represents two linear homogeneous equations. So this is one of the straight line and this is another straight line. So this is given straight. Okay. So this is equation 2. This is equation 3. This is equation 4. Now find this area as well as centroid G. Okay. So for finding the area and centroid, you need to find the point of intersection of these three lines. So clearly point of intersection of 2 and 3 is origin because of there is no constant. So you are solving equation 2 and 3. You get directly 0, 0. Next, solving equation 2 and 4. Okay. Here x, y constant. So you have to start from middle term or second term. So here minus 7, constant 0, next 6 minus 7. Here start from second term, minus 3, 4, 2, minus 3. So this is x by minus 28. So y by 0 minus 24, minus 24. And 1 by minus 18 plus 14. So clearly x is equals to minus 28 by minus 4, y is equals to minus 24 by minus 4. So therefore point A is 7, 6. Okay. So similarly you can solve equation 3 and 4. So you are solving equation 3 and 4. X, y constant. So here equation 3. This is minus 1, 0, 2, minus 1. Here minus 3, 4, 2, minus 3. Okay. So clearly x by minus 4 and y by 0 minus 8. Minus 8 constant by minus 6 plus 2. So clearly x is equals to what? Minus 4 by minus 4. X is equals to 1. Y is equal to minus 8 by minus 4. Y is equals to 2. Therefore point B is what? 1, 2. Okay. So clearly we will get 3 points. So now you need to find centroid and the area of the triangle. So therefore O is 0, 0 and A is 7, 6 and B is 1, 2. Here this is x1, y1, x2, y2, x3, y3. So first centroid. So what is centroid formula? So that is denoted by G, x1 plus x2 plus x3, y3, comma y1 plus y2 plus y3, y3. This is the centroid form. So this is equal to here x1 plus x2 plus x3. So add the x coordinates 7 plus 1, 8 plus 0, 8 by 3. And y1 plus y2, 6 plus 2, 8 plus 0, so 8 by 3. So this is the centroid and area of triangle OAB. This is equal to of x1 y2 minus x2 y1. So this is equal to of into x1 y2, 7 into 2, 14 minus x2 y1, 1 into 6, 14 minus 6, 8 by 2. So this is 4 square units. So this is the centroid and the area of the triangle formed by 3 lines. So try to solve this question. So for next session we will discuss more problems.